So 4.7 is triangle congruence Cpctc. Cpctc is an abbreviation for the phrase corresponding parts of congruent triangles are congruent. It can be used as a justification in a proof after you have proven two triangles are congruent. So it's just continuing congruent triangles, what we've been doing before. So Cpctc stands for corresponding parts of congruent triangles are congruent. So remember, SSS, SAS, ASA, AAS, and HL are corresponding parts to prove triangles are congruent. Cpctc uses congruent triangles to prove corresponding parts are congruent. So before we were finding the congruent parts and then determining that the triangles are congruent, now we're going to find that the triangles are congruent, and we can tell that all of their parts, all the corresponding parts, are going to be congruent. So it's just one extra step to what we've been doing before. We're going to go over some examples. So example 1, A and B are on the edge of a ravine. What is AB? So we're trying to find this length here. Do we know that these two triangles are congruent?
No.
So we have one pair of corresponding sides, another pair of corresponding sides. Do we know anything else from these two triangles to tell that they're congruent?
Yes.
What?
AB is 18.
Well, first we have to find if the triangles are congruent, then we can tell if AB is 18. Vertical angles, perfect. So these two angles here, the vertical angles, are congruent. So are these two triangles congruent? Yes, because we have a side, an angle, and a side. So by SAS, these two triangles are congruent. So Joseph, do we know what side AB is?
18.
18, perfect. 18 miles.
So will the corresponding, how do you know that the corresponding sides are always going to be congruent every time?
Well, we have to determine whether the triangles are congruent, and then all of their corresponding parts will be congruent too.
So do the vertical angles help determine that?
Yeah, the vertical angles tells us that we're going to use SAS.
Okay.
And then when we're using SAS, we know that the two triangles are congruent. And once we can tell that the two triangles are congruent, we know that all the corresponding parts are congruent. Okay, example 2. A landscape architect sets up the triangles shown in the figure to find the distance JK across a pond. What is JK? So do we know these two triangles are congruent?
Yes.
How do we know? Because vertical angles. Adrian, just pull up 4.7 notes. So what postulate or theorem do we use to determine these two triangles are congruent? SAS again.
And then wouldn't it be 41 feet?
So segment JK is 41 feet. Perfect, Allie. Because JK corresponds to MN, and MN is 41 feet. So JK is 41 feet also. Any questions? Okay, example 3. Given YW bisects XZ and segment XY is congruent to segment YZ. So we're going to prove that angle XYW is congruent to angle ZYW. So we're going to make a proof just like we've been doing before with the chart. And we're going to have our steps or statements on one side and our reasons on the right side. What's our first step going to be?
Well, one thing that I automatically
Yes. But in the proofs we were doing before, what do we always write first as step 1? The given. So what would step 1 be?
YW bisects XZ and XY is congruent to YZ.
So step 1 is YW bisects XZ. And our reason?
Given.
Okay. So we're starting off with the given. Okay. This is a proof, just like we've been doing before.
Like with 4.6, right?
Yeah.
Okay.
So we're taking the first step of the given
Okay.
and writing it in step 1,
Mm-hmm.
and our reasons given, because it was stated right here in the given.
Okay, I see.
Now, what does it mean to bisect?
Like make it cut in half.
Cut in half. So if we're cutting segment XZ in half, what are we making?
Congruent. Two congruent triangles.
2 congruent parts. So we have XW is congruent to WZ, because this segment YW is cutting this one in half. So we're making 2 congruent segments.
Would that be definition?
So step 2 is going to be XW is congruent to WZ. And what's our reason, Allie?
Definition of bisector.
Definition of bisector. We still have one other part of the given to write, so let's write that down next. So step 3 will be XY is congruent to YZ. And what's our reason? Given. And let's put our tick marks here so we know what we're doing. So we put 2 tick marks on XY is congruent to YZ. So we have 2 pairs of sides that are congruent. Do we know anything else looking at this triangle? We have 2 pairs of sides. We need that third side. How do we find that third side, Allie?
It would be, well, I was gonna say that because they share the line, like YW is congruent to segment AW.
Perfect. So YW is congruent to segment YW. And why do we know that those 2 segments are congruent? Reflexive property.
And that can also be determined for SSS. Right?
Yep, so now we have 3 pairs of congruent sides. So can we determine that these 2 triangles are congruent?
Yes.
Yep.
So step 5 is going to be triangle XYW is congruent to triangle ZYW. And what's our reason?
SSS.
SSS. So let's go back to what we're trying to prove. That angle XYW is congruent to angle ZYW. How do we know now that those 2 angles are congruent?
SSS.
Well, we know that the triangles are congruent. What's this lesson called?
Oh, C.
Triangle congruence.
C.
P.
So corresponding parts of congruent triangles are congruent. So angle XYW, this angle corresponds to angle ZYW. So we know that these 2 angles are now congruent. So step 6 will be that these 2 angles are congruent because of corresponding parts of congruent triangles are congruent. So Cpctc. Those are the angles. I'll write them in a second. So because of Cpctc. So angle XYW is congruent to angle ZYW. So once we found in step 5 that the two triangles are congruent, now we know that all the parts are congruent in both triangles. All the corresponding parts. So that's why we can say that these two angles are congruent because of Cpctc. Any questions on this one? Ready for the next example? Okay. Example 4. Given PR bisects angle QPS and angle QRS. Prove that segment PQ is congruent to segment PS. So what do we do first?
The given.
Yeah,
The given. So we have our steps on the left and our reasons on the right. And step 1 is going to be our given. So PR bisects angle QPS. Let's just start with the first angle first. QPS bisects. So what's our reason for step 1? Given. So if PR, the segment in the middle, bisects QPS, so we're talking about this angle to the left. So the segment here is bisecting this angle. What do we know now? What else can we conclude when it tells us that this segment is bisecting this? What does it mean to bisect?
To cut in half.
Cut in half.
Oh,
So
PQ is
they're congruent. What's congruent?
PQ and PS.
PQ and PS.
Well, this segment is bisecting the angle, not the segment. So now we have two congruent angles.
Oh, RSP and RPP.
Perfect. So we have step 2 is going to be that RPQ, angle RPQ, is congruent to angle RPS.
And that's definition of bisector.
Definition of angle bisector. Perfect. So I'm going to put the arc marks right there, saying that that angle is congruent to that one. Okay, so we just wrote down the first part, so PR bisects angle QPS. We still have one more angle that it's bisecting. So let's write that as step 3. So PR bisects angle QRS. And what's our reason for this? Given.
Given.
So now this segment is cutting this angle here, the blue one. So it's cutting it in half. So what do we have now? What do we know now? What can be our step 4?
Segment PQ is congruent to segment PS.
So we have PR, this segment, is cutting this angle. So when it cuts it in half, what are we making, Austin?
QR converted to RS.
We're cutting the angle in half, not the segment.
PR converted to PR.
Oh, PQR is congruent to RSP.
Right, so we have two congruent angles. So PQR is congruent to PRS. So angle PRQ is congruent to angle PRS.
And that's definition of angle bisector.
Yes, definition of angle bisector again.
So basically you're just breaking it up. It's the same thing, but you're breaking it from one angle to
Yep,
another.
so I just took, because PR is bisecting both of these angles, so the pink angle and the green angle. So I just broke it up into 2 different steps, which if you wanted to, you could write the 2 givens together, but you just have to include that RPQ is congruent to RPS and PRQ is congruent to PRS. So both of these steps too.
It's just easier to break it up.
Yep. Whatever is easier for you, you can do. There's more than one ways to write a proof, just as long as we get to the same conclusion. Kevin, did you have a question?
I can receive it.
Okay. Can you see now?
Yeah.
Jake.
So those are different, but they're the same. Right.
He just broke it up into.
Right, so this green angle's different than this one, but what matters is that this green angle is congruent to this green angle. Because we're looking at the top triangle as one triangle, the bottom triangle as our second triangle. So we need to find corresponding parts in order to tell that the top one's congruent to the bottom one. So right now we have an angle of the top one that's congruent to an angle of the bottom, an angle of the top one that's congruent to an angle of the bottom. Okay? So we have two angles, two pairs of angles right now.
He just broke it up into two.
Do we know that these two triangles are congruent yet?
Yeah.
Yes.
How do we know?
Reflexive.
Reflexive. So we need one more segment in order to tell that these are congruent. So we can say that
PR is congruent to PR.
PR is congruent to PR. So step 5, segment PR is congruent to segment PR. And Andy, what's our reason?
Reflexive.
Reflexive property. So now can we tell that these two triangles are congruent?
Yes.
How?
ASA.
ASA, perfect. We have an angle, a side, and an angle. And that side is included in between the two angles, so it's ASA. So triangle PQR is congruent to triangle PRS PSR. So triangle PQR is congruent to triangle PSR. And what's our reason? ASA. So let's go back and see what we were trying to prove. That PQ is congruent to PS. Did we prove that yet? No. So step 7 will be PQ is congruent to PS. And how do we know that those two segments are congruent?
Cpctc.
Cpctc. Perfect. Corresponding parts of congruent triangles are congruent. Can you see? Yes. Any questions on this? This is 4.7. That's it.
That's it? Wow, that was easy. Only 7 pages?
Wait, so this
Oh.
whole